graders, good day, how are you? Excited to get into another lesson with you all. Today's going to be super cool because what we're doing, we're in lesson 17, and what we're doing is connecting multiplication and division. We're going to take a look at a few visuals and we're going to think about, wow, multiplication and division are really closely related. Do you remember a few lessons ago when we were exploring the fact that sometimes the quotient, which is just a fancy name for the answer to a division problem, sometimes the quotient shows us the number of groups, but sometimes the quotient shows us how many in each group? So we're going to continue exploring that, and we're really going to see how closely connected multiplication and division are. So let's take a look at some problems.
Okay, friends, before we get into a few examples, I want to just review very quickly some things that we've talked about so far, and we're going to apply these things to now connecting multiplication and division. So, do you remember a few lessons ago when we talked about how sometimes the quotient can show us the number of groups? Do you remember that? It's just a few days ago. And then also sometimes we talked about how the quotient can show us the size of each group. We just discussed this a few days ago, so I hope that this is pretty familiar. I want to take a look very quickly at some number bonds, and I want to explore this a little bit further. So let's think about the division equation 20 divided by 5. Okay, so 20 divided by 5, I think many of us know 20 divided by 5 is 4. But I want you to think about the fact, and let's think about this in a number bond. Sometimes this 5 is going to show us the number of groups, but sometimes the 5 is going to show us the size of each group. Just like sometimes our quotient will show us the number of our groups, but sometimes our quotient, friends, is going to show us the size of each group. So 20 divided by 5. When we're looking at 5 as the number of each group, our number bond will look like this. We will have 1, 2, 3, 4, 5 groups that make up 20. What number is inside of each group? Well, the number that is inside of each group is 4. Can you see that we have 1, 2, 3, 4, 5 4s that make up 20? In this example, friends, 5 is showing us the number of groups. If we look at the same expression, 20 divided by, yes, it'll be the same expression, but I want to show this in a different way using our number bond. Sometimes this 5 is going to show the size of each group. The way that looks in our number bond, friends, is that I will have, I will have a 5 here. And now we're going to have to consider, how many 5s do we need to make 20? Well, I have 5, 10, 15, and then here's one more 5 that makes 20. Here, friends, our 5 shows the size of each group. And again, we've seen that there are 1, 2, 3, 4 5s inside of our 20. Let's continue to connect this division and multiplication. And again, this multiplication, friends, is repeated. We're making copies of 4 here in 20. And here in our number bond, you can see that we're making copies of our 5. Let's look at some problems where we're going to continue to connect multiplication and division. I thought this was a good place to start here with our examples. In this problem, we're given some information. Let's read it together. The waitress arranges 32 glasses into 4 equal rows. How many glasses are in each row? Okay, so here, friends, we again are connecting division with multiplication. We have 32 divided by 4. and we are trying to figure out how many glasses are in each row. So let's go ahead and show this with an array. I know that we have 4 equal rows. I know that rows go like this. So let's go ahead and set up our 1, 2, 3, 4 equal rows. We need to share 32 evenly across these rows. So I'm going to go through and quickly show 32. So we have 4. I'm going to skip count. Now we have 8. And then we have 10, 12. 12 plus 4 more here is 16. You can see a 4 by 4 array. And we're going to add 4 more, which is 20. And then we have 24. And next we have 28. We are almost there. Here we have 32. And we're done. Great. So I have 32 glasses here. I'll be the waitress, arranged into 4 equal rows. 1, 2, 3, 4 rows. What we need to find out, friends, is how many glasses are in each row. Well, I just circled one row and I say 1, 2, 3, 4, 5, 6, 7, 8. We've just shown that 32 divided by 4 is equal to 8. Very interesting. Something else that we can look at here, friends, is the fact that 32 divided by 8 is equal to 4. I've shown that. Here, friends, we have 4 rows, but we also have 1, 2, 3, 4, 5, 6, 7, 8 columns. So if we were to look at one of our columns, 32 divided by 8, how many glasses are in one column? Well, you saw me set up this array, and you know that there are 4 glasses in each column. Finally, what are we looking at here in terms of multiplication? Let's choose a fun green. Well, what I see here in terms of multiplication, friends, is that I have 4 rows. In each row, I have 8 glasses. So I have 4 times 8. 4 copies of 8 is equal to 32. But guess what? We can also write this one more way. You all know with the commutative property, we can flip multiplication expressions and still come up with the same answer. So yes, we have 4 rows, but we also discussed the fact that we have 8 columns. So we can also look at 8 times 4, 8 copies of 4, oops, pardon me, I pushed that funny button to my pen. 8 copies of 4 is also equal to 32. I hope you're seeing how beautifully connected multiplication and division are. We can name what's going on here in this restaurant in a few different ways. That's pretty cool. One more problem here before we get to the secret word in your next mission. Here we have the store clerk arranges 24 toothbrushes into 4 equal rows. Equal. Whenever we're dividing something equally, we know that we are looking at a division expression. How many toothbrushes are in each row? Okay, friends, so what we're looking at for this division expression is 24 divided equally into 4 equal rows. How many toothbrushes will we have when we divide 24 equally across 4 rows? Let's go ahead and take a look at that in terms of rows. We have another wonderful row problem. So I have 1, 2, 3, 4 rows. I need to distribute 24 evenly across these 4 rows. So far I've distributed 4 of my toothbrushes. Let's keep placing these toothbrushes along these rows. So I have 8 now. And now I have 10, 11, 12. You can count along with me. 13, 14, 15, 16. We are making progress. 17, 18, 19, 20. And there we have 21, 22, 23, 24. Beautiful. So now you can see our 1, 2, 3, 4 rows, and these circles represent our toothbrushes. So if I were to look at one row of toothbrushes, Oh yeah, one row of toothbrushes. How many toothbrushes are in this row? Well, I see 1, 2, 3, 4, 5, 6. 24 divided by 4, friends, is 6. We are going to have 6 toothbrushes in each row. In turn, friends, I think a few of you are predicting what I'm going to document here next. We can also think about looking at our 24 toothbrushes divided into our columns. I think a lot of you are recognizing the fact that we have 6 columns here. So if we were to divide our toothbrushes evenly across 6 columns, and we are going to look at how many toothbrushes in one column, you can see here we have 4 toothbrushes in one column. Finally, connecting this magnificence to our multiplication, what we're looking at, friends, is when we have 4 rows and we have 6 toothbrushes in each row. How many toothbrushes do we have? Well, you can see it right up here, friends. We have 24 toothbrushes. And you all know that the commutative property allows us to flip these numbers. We can flip numbers when we're multiplying or adding. So let's also look at 6 columns times 4 toothbrushes within each of those columns. How many toothbrushes will we end up with? We are still going to end up with 24 toothbrushes. Are you ready for your mission? Your mission is to complete number 4 for lesson 17 and show it to Mrs. Gilmore. Next, you're going to check in the secret word with Mrs. Gilmore. As you can probably see, the secret word for today is donut. Finally, you'll log into Google Classroom for your extension activity. Good luck, mathematicians!